That first video cut off, I'm gonna jump right back in. We're identifying conic sections, and this one we know is a circle because the coefficients on the x squared and the y squared term are the same. For part C, we only have an x squared term and no y squared term, so it must be a parabola. And for part D, we have an x squared and a y squared term. They're both positive, but the values of the coefficients are different. That tells us it must be an ellipse. Example 2, we're asked to write the equation in standard form and then graph it. So we can identify, before we even begin to solve this problem, it's going to be a hyperbola. And I know it's a hyperbola because we have one positive and one negative term with the x squared and the y squared. So this is essentially just a review of graphing hyperbolas. First, we're going to group together the x squared terms, the 3x squared and the 18x, and we can factor out a 3. That leaves us with x squared plus 6x, and I'm going to leave a space. Next, I'm going to group together the y terms, and I'm going to factor out a negative 2. I have y squared, and then minus 4y, and I'm going to leave a space. The constant term, negative 35, I'm going to move to the other side, so it becomes positive 35 over there. Next, I want to complete the square, so I'm thinking of the magic number that completes this trinomial. If I take 6, cut it in half, and square it, I get 9. So I'm going to add 9 here. Don't forget to balance the equation. 3 times 9 is 27. Since we added 27 to the left-hand side, we're going to add 27 to the right-hand side to balance the equation. Completing the square with the y's. Take negative 4, cut it in half, and square it. We get 4. Don't forget to balance the equation. Negative 2 times 4 is negative 8. So we're going to balance the equation. We added a negative 8 on the left-hand side, and we're going to add a negative 8 on the right-hand side as well. I can factor this trinomial. It would become x plus 3 times x plus 3, which simplifies to x plus 3 squared. Factoring this trinomial, y minus 2 times y minus 2 simplifies to y minus 2 squared. And then combining these three constants, we get 54. I know this is a hyperbola, and I know it should always equal 1. To turn this into a 1, we're going to divide by 54. Divide by 54, divide by 54, and then simplify. Simplifying 3 and 54, I know that 3 times 18 is 54, so we can simplify, reduce this to a 1, and reduce this to an 18, and we get x plus 3 squared over 18. 2 and 54, well, I know that 2 times 27 is 54, so this becomes a 1, and this becomes a 27 if I reduce that fraction. So here is my standard form of hyperbola. Let's think about graphing it. The center of the hyperbola is the opposite of this and the opposite of this, so x value would be negative 3 and the y value would be positive 2. I'm going to go ahead and use this grid to create the graph. So negative 3 and positive 2, there's the center. I know in the x direction, I have to travel whatever the square root of 18 is. Well, the square root of 18 is approximately 4.2. So in the x direction, I'm going to go 1, 2, 3, 4, and a little bit more. And the same thing in the other direction, 1, 2, 3, 4, and a little more. In the y direction, so this was my a. B is going to be the square root of 27, which is approximately 5.2, and this is under the y, so in the y direction, I'm going to travel 5.2. 1, 2, 3, 4, 5, and a little more. 1, 2, 3, 4, 5, and a little more. And these 4 points create that fundamental rectangle that guides our asymptotes, which guide the hyperbola. So here's our fundamental rectangle, and now we're going to draw asymptotes through the corners of that rectangle and through the center. For this example, because the x term is the positive term, I know that this is a horizontally oriented hyperbola. So the graph has vertices here and here, and looks like this. Example 3, you write the equation in standard form and then graph it. So any of these examples in this section could be any of the conic sections. For this example, since we only have a y squared and no x squared, that means it's going to be a parabola. We have a couple different ways to write parabolas, and whatever the single variable is, you want on the left-hand side, and on the right-hand side, you want your squared term. So I'm going to take this negative x and move it to the left-hand side. It will become positive x over there. And I'm going to move this 4y squared term to the right-hand side, subtracting. It would be negative 4y squared, and I'm going to bring down the 24y and bring down the negative 31. Completing the square here, I'm only going to be working with the y's. I'm going to factor out the negative 4, which leaves us with y squared minus 6y. I'm going to leave a space and bring down the negative 31. Completing the square, take negative 6, cut it in half, and square it. And we get 9. Don't forget to balance the equation. This is negative 4 times 9, so negative 36. But we want to just keep a single x on the left-hand side. So to balance the equation, I'm going to do the opposite on the same side. So to balance this negative 36, I'm going to create a positive 36, which essentially adds 0 onto the right-hand side. Factoring this trinomial, it would be y minus 3 times y minus 3, which is y minus 3 squared. And combining these like terms, we get 5. Here's our standard form of a parabola. And now I'd like to graph it. The vertex, being really careful here, this negative 3 is tempting to write down for your x value, but it's attached to the y. So our x value here is actually 5, and our y value is the opposite of this, 3. The vertex is 5, 3. So over 5 and up 3, and there's the vertex. Let's go ahead and find the directrix and the focus too. The directrix. Well, this negative 4 is our a. So negative 4 is a. Let's write that down. Negative 4 is a. And we have that formula 1 over 4a that represents the distance. Remember, it represents that distance between the vertex and the focus and the distance between the vertex and the directrix. If I plug in my negative 4 for a, 1 over 4 times negative 4 is negative 1/16. And we can think about traveling a distance of 1/16 in either direction. I know that this is a right or left opening parabola. Because there's a negative here, it's going to be opening to the left. So it's going to look something like this. That means that the directrix will be off to the right, 1/16 away from this vertex. So we can think about the x value 5 plus 1/16. So I'm just going to call that 5 and 1/16. That is the equation of the line. It goes through the x-axis, so we're going to call it x equals 5 and 1/16. That's our equation of our directrix. The focus is that same distance, 1/16, in the opposite direction. So the focus is going to be a point right over here, 1/16 to the left of 5. So we can think about taking that 5 and subtracting 1/16. And the y value doesn't change. The y value is still 3. So 5 minus 1/16 would be 4 and 15/16. The y value is 3. And that is the coordinates of our focus. Finishing off the graph of the parabola, we can just think about plotting some points now. Let's think about an